detail for providing this opportunity to us. My name is Ankit. I'm currently working as an engineering manager at Incora. I have around 10 years of experience in IT, and my area of expertise includes full stack development. I mostly do development on Java, Node.js, React, and AngularJS. Also, microservices and serverless design, cloud architectures, and data science and machine learning. That's something new I'm learning, and also building a project around those things. Okay, so we'll go to the agenda for today. On today's session, we'll talk about what is communication protocols. We'll see what is the history of the communication protocols, what are the different protocols we were using already, and what is something that's new coming in the future. Next, we have a client libraries. So we'll see what are the client problems with the client library, existing client library that have been provided by this existing protocols. We'll see how gRPC is overcoming those problems. Next, we'll see gRPC overview. We are going to cover what is gRPC and what are the features provided in its architecture. Just give me a moment, guys. I'll share. Sorry, my video was not on. Okay, so on this chapter, we'll see a holistic overview of the gRPC. What are the features gRPC provide? What are the architecture it have? Next, then we'll jump on the protocol buffers. It's an important part of gRPC and how protocol buffers plays an important role in gRPC communications. We'll see it in this chapter. Next, we'll go over the gRPC strength. What are the gRPC has in strength over the other protocols, and what are the pros and cons of gRPC? For any communication protocols, we'll go over the security. So for any communication protocol, security is very important thing, right? So we'll see what are the different kind of security gRPC provide. Then we'll talk about what are the recommended use cases of where all we can use the gRPC. And then we'll conclude our talk. So first thing is, what is communication protocol? So communication protocol is a set of rules and regulation that allow two electronic devices to connect to each other to exchange the data with one another. These communication protocols are built on TCP/IP, right? For example, you're using a mobile device or you're using a web application, right? Your mobile devices communicate with the backend services, or your web application communicate with the backend services to exchange the data between each other, right? So here we mostly use the RESTful APIs, but it's not limited to the RESTful API. We can use GraphQL APIs, and there are a few more protocols, right? We'll talk about in our next slides. So there are different kind of protocols. First, we'll talk about the unary communication. This is a single way of communication where the architecture is like a simple request response. You call the front end will call a backend, or a client call a server, and they communicate over TCP/IP or over HTTP calls, right? So in the history, like the first protocol which was built was a SOAP. SOAP was one of the oldest web API protocols that remain in widespread use. It was introduced in early 90s and still being used in many enterprises application. SOAP was one of the first protocol designed to allow different application or services to share resources in a systematic way using network connections. Technically speaking, SOAP is an example of remote procedure call. We'll talk about the remote procedure call, and even the gRPC actually followed the similar remote procedure call standards. So RPC, when I talk about RPC, is a broad category of approaches allowing different computers to communicate with each other. SOAP stands for Simple Object Access Protocol. So it's basically a standardized protocol. It uses XML as a communication format or message format to interchange the data between one service to another service. So it defined a standard schema, it defined a standard contract that the server defined this standard schema, and the client has to follow this schema. So it has a rigid structure, right? Uh, and the client has to follow this structure to communicate successfully with the server. There are various advantages of SOAP as well. SOAP is a platform and operating system independent. So you doesn't matter whether you are using a Java, Go, Python. You can use SOAP any framework or language, and it is irrespective of operating system, whether you are using Windows or whether you are using Linux, right? You can, or whether you are using mobile device, so you can use SOAP anywhere, right? So it's a completely platform independent. It works on the HTTP protocol, and it can be transmitted through different network and security devices. So it supports for almost all the security devices. It doesn't have any such kind of a restriction, right? So it was very popular in 90s, and even till 2000, it was very popular until REST came into the play. There are certain disadvantages SOAP has, and that is the reason REST came into the play to overcome those disadvantages REST have. So I'll talk about what are the disadvantages SOAP has. So first thing is that not cacheable, right? REST APIs we can cache in, but it's not possible with SOAP to cache in, since it uses the XML format, right? And it's very poor in the performance, right? It has a lot of latency issue because a server has to pass the XML data, and the XML is a very heavy loaded, right? It's not a easy compared to JSON or which have a very the data format is very small compared to the XML, which have a you need to write all the protocols or standard way that SOAP has to give, right? It's not as flexible as REST or JSON. I mean, like REST have JSON, right? Is it hard for test in browser? You cannot actually test SOAP into the browser, and it's very hard for developers to debug the SOAP APIs. Because of these advantages, Roy Fielding come up with the REST representation of state transfer to make a stateless application. So it was introduced in 2000. REST was introduced around 2000. Like SOAP, REST relies on standard transport protocol. Similar to SOAP, it uses HTTP to exchange the data between client and server. However, REST is more flexible because you can use either JSON or XML as a way of communication, or for sending the data or exchanging the data between your server or client application, right? You can use either JSON or XML. Most JSON is being used widely because it's easy to read, and since we started using JS application or JavaScript application on the web browser, it became popular. So everybody wanted to use JSON instead of XML. According to 2000, in 2007, there was a report from Cloud Elements. REST APIs are accounted to 83% in use. So across all the different protocols, REST is being used more than 83%. And it provides superior performance compared to SOAP. It have a caching features, and performance was much better than SOAP. So it became very popular, and it's still popular till today. Next, we have GraphQL. So GraphQL has been developed by Facebook in 2013, and it's been published publicly available by 2015. Facebook made it public in 2015 around, and so GraphQL, which is officially defined as a query language, also represent an efforts to overcome some of the limitation or inefficiency REST have. So a REST were having certain inefficiencies. So that is the reason GraphQL has been introduced, which overcome the problem REST were having. So it allowed to allow the client to ask only the data it needs it. So for example, REST API, you call your backend service, it gives you all the data that server want to send. But in case of GraphQL, the client has the flexibility to ask for the data it want, right? You don't need the whole data, right? For example, if you're building a mobile application or web application, you might not require to use all the data server sends. You might require for based on that particular features you're building, right? You require only a certain data, right? So you can query in GraphQL what data you need for this particular feature. And for REST, the problem is like you need to expose the endpoint for each feature you're building, right? You create a different get, post, put API. But in case of GraphQL, you expose a single endpoint, and single endpoint is responsible for delivering all your data. So you pass your request as a query parameter, whatever the query you need, right? In a single endpoint, right? You do not need to expose a multiple endpoint. So it help you to help you to lower your maintenance. Actually, you don't need to maintain multiple APIs, right? With the GraphQL, since it have a flexibility to get the data, so it minimize the payload as well, and it improve the performance because it improve the latency as well, because of your data is very limited that you are required on your front end. And then we have a SSE. SSA is represent server sent events, right? So basically is a technology, SSA is a technology, pushing technology that enables pushing notification or message or events from server side. So generally all these three you see like SOAP, REST and Grapher is just like mostly the client actually asks for the data, but in case of SSE, server puts the notification. So you have certain application where you require your server to push the notification or to your client, right? So in this case, browser subscribe to a certain channels or certain events actually using event source interface, and then server can bidirect. It's a unidirectional, not a bidirectional. From send a message from server side or events. So we'll see the certain examples of where this SSE are being used. Like for example, if you're building a tracking system, right, where you wanted to see the location into real time, right? Instead of we can do using HTTP pooling, but what SSE provides is whenever it have a new update, it send the update to your front end application, right? So you listen for the only the changes that server sending, and you basically update your application. You don't need to do HTTP calling or doing a long pulling, right? Second example we can have is a alarm or alert project, right? Let's say you added a certain alarms into your application, right? So backend are listening for those alarms at certain those times. Backend will send a push notification, a certain kind of notification to the browser. Then we have a lot of use cases around IoT projects. So IoT projects where you need a real-time sense of data or anything, wherever you have real-time notification you want, right? You can use SSE. Then we have a stock market where you watching the live prices of the share, right? So here you can get benefited with the SSE, right? Where whenever server have an update from the backend about the stock prices, it updates to your front-end application. Then we have a delivery project where you wanted to have a delivery update about your product or something, right? So you whenever your delivery have a new status, it get updated to the client. For example, like we have a push notification in mobile application. It's a good example of SSA. And then we have in-app notification that we all know. It's a kind of a push notification. So all this mostly are used into the web application. Then next, we have a bidirectional communications, right? So these are the kind of protocols, right, which help you to communicate in two ways. You can communicate with the server to client, or server can communicate with client. So it's a bidirectional communication, two-way communication, we can say. So where WebSocket is basically is a thin transport layer things are built on top of your device TCP/IP stack, which provide full duplex, a low latency, and event-driven connection between the server and the browser. It is a stateful protocol, which means the connection between client and the server will keep alive until it is terminated by either of them, right? So either client can terminate the connection, or either the server can terminate the connection. Once the connection is closed, you have again to initiate the communication, to start the communication again, right? So this is ideal for the real-time application, since after the initial HTTP handshake, a single WebSocket is required to handle all the messages from client to server or server to client. You don't need to create a multiple handshake, right? You just create one handshake, and then rest of the things can take it care by the server or client, right? To send a stream of messages. There are certain example for where we can use a WebSocket. For example, you have a real-time web application where you're doing a chat application or gaming application, and then probably where you have a two-way communication, right? Example, chat application, right? To communicate with two person at a time, right? So in this way, you update your data to the server, and server update back to other friends, right? Next, we'll talk about the role TCP and UDP. These are, I think, foundational pillars of the internet. These are the introduced long back, way before then SHOP and all, right? These are the foundational pillar of the internet, right? And it's provide you streaming process. TCP help you wherever you have a streaming process. You use a TCP because the performance wise TCP are way better than any other protocols. And UDP also help you. It's a kind of UDP is using a user datagram protocol, and whereas TCP is a transmission control protocol. Now we have newer gRPC. We'll see what are the problems with traditional protocols and what are the gRPC offers. So gRPC can handle real-time communication. It can also handle unity communication, right? For example, for unity here you are using SHOP and REST, but gRPC you can use either two-way communication also, and you can use a unity communication, and you can it has a support for multiple language environments. Like you can use Java, Go, or any framework you take it. You have implementation for the gRPC, right? For building any internal APIs, you can use gRPC. Okay. Next, we'll talk about a bit on the client libraries and what are the problems with the client libraries. Right? For using any of this protocol, like for example, SHOP or RESTful APIs, you need a client library on the client side, which help you to communicate with your server. For example, if you have a RESTful APIs, right, you add a client library into your backend application. Like for example, if you're using Java, Go, you don't need to do for the web application, because web application browser itself is one of the biggest client of HTTP clients, right? So it has implementation for the HTTP. But for if you have a backend service, you need to implement your own library, or you need to add a library for HTTP to communicate. So the problem with these libraries are these are maintained by the third party. Because let's say your client is Java, right? And it's been you started using it like you started using a certain version of it, and then there was a new update, right? Let's say this protocol was based on HTTP 1, right? And now they have updated to HTTP 2, right? So you again need to go and see whether there is an update to these libraries, and you have to update your client library. Think as a point where there are no maintainer or nobody is maintaining these libraries, right? You will be in trouble. So you need to find out another maintainer who has a new updated version of this HTTP library, and you need to update into your application this library, and it may require you to code change, right? But in terms of the software development, it's not an ideal way to use library or which required a maintenance, right? Or in you don't want your code to be changes whenever there is an update, right? You want to fix things which handles or library which handles take care of the patches or security updates, right? You need a single place where you can find out a library, right? So that's how where the gRPC overcomes. So it has to only gRPC maintain their library. They don't have a multiple vendors, right? Whether you need a library for Java, client, or Go, or any library, they have a single maintainer, right? You don't need to go anywhere else to have find out the maintainer who is providing the HTTP implementation for this one, right? So you can get benefit out of those things. Okay. In this, we'll see what is gRPC, and in the slide. First, we need to understand what is gRPC. So gRPC is a modern open source high performance remote procedure call. Uh, it was developed by Google in 2015, and it's become a part of CNCF in 2017. Uh, it's an open source project, right? So and Google has contributed a lot on this project, and then they have open source in around 2015, and then they are Google are internally using this gRPC in a lot of their internal projects, and also I even after making it open source right in 2015, within a year, like a lot more companies started using it. For you call it big companies like Netflix, Square, Cockroach. The reason why people started using gRPC because of the performance it have. It was giving a better performance compared to the other APIs. We'll see now upcoming slide how gRPC performs better compared to other RESTful APIs and what are the other things it offers. Uh, uh, so what it uses, uh, gRPC uses HTTP2 as its underlying protocol. So since it's using as HTTP2 its underlying protocol, it's give a lot of other benefits compared to HTTP1. So uh, HTTP2 is the latest version of HTTP1, and it have a lot more feature introduced compared to HTTP1, whether it's a performance, whether it's a security. Uh, okay. And then interface definition language, right? So like example, REST. We REST, we are using JSON for communication protocol, right? We can use XML too, but Protobuffer, in case of gRPC, we are using Protobuffer. It's been again developed by Google, the Protobuffer, and it's being used as an interface definition language for gRPC. Protobuffers are quite small in size compared to JSON and XML. And the reason why is like JSON or XML, it's not being formatted or serialized into a binary format. But in case of Protobuffer, it serialized into a binary format and then transferred. So that this helps to reduce the size of payload. And then data description protocol, like similar to when we have an RESTful APIs or graphical APIs, we send the authentication detail or many other details over the header. Similarly, in case of gRPC, you can use metadata where you can send additional data along with your payload. For example, authentication token you have, and language is what kind of language you want to server to respond with, right? So those kind of things you can actually describe in your metadata. So the support, gRPC have a support for Java, Go, Python, Ruby, Node, C, C++, C#, a lot more languages.
No, I think Karthik can start with it.
Okay. Now we'll go how gRPC differs from over competing protocols, like what gRPC offer which other protocols are not having it, right? So we have talked about the problem with the client library, right? uh, in other protocols, like all of them have their own maintainer, and not a single maintainer, like all of them have their multiple different maintainer, right? Which cause a problem when you try to update it, or when you find to patch it, right? And let's say there is no maintainer active on this library, right? You will come into the problem. You need to find out another maintenance library, and you need to update it, and it might require a code changes, right? So here it's been maintained by the gRPC community itself, and it have a single implementation. You don't need you will get it a library for Java or Go, but it has been developed by gRPC. They update it, or they provide a security updates, they provide us patches, right? So you don't need to find out the multiple maintainer. Next, we have it's built on it uses HTTP2 as an underlying protocol at the moment, and HTTP2 provide many features compared to HTTP1. One of the features, HTTP2 has a multiplexing. So we'll see how it's basically uh, better than HTTP1. The problem with the HTTP1 is like load resources one after another. So you call an API or multiple APIs, right? But it basically happens one after one another after, like one request goes and then second request goes. The problem with, like, if it blocks, if one resource get blocked, it block all the other following resources. So this is a problem being solved into with multiplexing in HTTP2. So HTTP2 is able to use a single TCP connection to send multiple streams of data at once, so that only resources block any other resources. So one resource get blocked will not block other resources, but in case of HTTP1 get blocked, it block all the resources. How does this happen? Basically, HTTP2 does this by splitting data into a binary code messages and numbering these messages so that the client knows whose stream each binary messages belongs to. Uh, Next, we have a message format. Message format we have already spoken about. Like it uses the protobuffer, which is very small in size because it transfer data using the serial, using compressed headers, and also the size is basically compressed into a binary format. The data exchange using a binary format. It's not using raw data. So these are the few benefits of gRPC over other. Sorry. We'll see how gRPC architecture, or we'll see how the gRPC process works, right? So here on the left side, I have a gRPC clients, and here I have a gRPC server. So first thing is, sorry. On the server side, the server implements all the methods declared by the service and run a gRPC server. So in gRPC, what happens? You create a proto file and you define all your requirement, or for example, your services that you wanted to expose in this proto file, and then gRPC server convert those into a into a services that handles all the client calls, right, which are calling this to calls. So here a Ruby client, like for example, you have a Ruby client, right? It's call a local procedure call to the stub. Stub is basically a client has a local object known as an object, right, that implement the same method as the service which are defined in your proto file. It calls the local procedure call, and then client stub serialize those parameters, and then it asks OS to call the gRPC server with those data or parameter that you have it, and your OS basically makes a call to HTTP server, your gRPC server, and on the server side, it received the data, OS received the packets and give it to the your server stub. Server stub unpack the data, deserialize it, and then gRPC server read the data and perform your whatever you have asked for, and then it basically return back the response to your client. And then it's the response is again being handled by the client system, and it unmarsal your response, and then this is how gRPC works actually. We'll talk about the protocol buffers. So protocol buffer is ideal. Is basically a message format that we use in gRPC. It's kind of similar like JSON or XML that we are using into RESTful APIs. Okay, so it is been developed by the protocol buffers again developed by the Google. They are language neutral, so they come up with their own compiler and convert the message into a native language. You don't need to worry about like Protobuffer compiler take care of all the compilation and convert into the native languages, and you don't need to worry about any data conversion, and they are platform neutral. So whether you are using Linux, whether you have Windows, right, it works across any platform. They have their own way of serializing the data. It serializes data into a binary format before exchanging the data. So here is a simple example of how we create a protofile. Here we have two object, hello request, which have a data type called a string. Data type is string and the variable name is name, right? And this is again hello reply, where you have a string and message. So these are the services defined. Think this as a APIs. You're exposing an API, right? So in gRPC, what happened? You call a function. You don't call an API. You call a function like it's local to you. In Java or any language, right? You call your method. Similarly, in gRPC, you call a method actually, and the internally gRPC handle and make it a HTTP call. So here, for example, you are exposing it to API. Say hello and say hello again, and where your request parameter is hello request. The structure of the hello request is like this. You have only name parameter, and hello reply again have a message, right? So that you are expecting as a return type, and this structure has to be defined on both your client side and the server side. And this we'll see how protocol buffers works. First of all, you create a protofile, define your structure. We have seen in a previous slide. Once your protofile is created, you have something called protocompiler. The protocompiler compile this code into your languages. Like if you're using Java, so it convert into .java file. If you're using Python, it convert into the Python.py file, right? Once that is done, again, the compiler give it to your native language compiler to compile this file, and it's compiling to your compiled class. So for example, you have a .classes file for Java, right? Once your Java file get converted into compiled classes, and then your protofile or basically gRPC use this as a serializing or deserializing the data whenever it receives the data from server or server receive the data from client. So it uses that protofile to deserialize or serialize the data. Now, in the following chapters, we'll look into what are the strengths of gRPC. So gRPC offer a lot of features and strength, right? It has first thing is performance. We'll see. We'll do a comparison between REST and gRPC. How it's better compared to RESTful APIs, and we also look into certain metrics how gRPC performs better in compared to REST. Then we'll talk about the streaming, what are the different streaming process gRPC supports, and then we'll look into the code generation, and then we'll talk about the interoperability, and then we'll talk about usability and productivity gRPC offers, and then we'll talk about what are the inbuilt features or built-in features gRPC have to offer. So let's talk about the performance. Here, there was a test we ran. So this test was run actually. So we created a Go program uh, and run into the Google Cloud computing. Google Cloud actually supports for both gRPC and RESTful APIs. So generally, we see that gRPC is approximately 7 to 8 times faster compared to REST. So here, what we have done is we created a client that has 10 threads, which will send a large size message with a name string and an array of 10,000 integers. And each thread has been repeated 5,000 times for sending this message. And the whole program has been written into Google Cloud, and we have used one CPU, one instances. And the performance you can see here, request per second that gRPC was able to handle 48, and the rest were able to handle 4. So the throughput is basically gRPC have is 48, which is quite amazing. And if we look at the latency, so this is approximately same list, and both gRPC have the same latency, but the number of messages CPU were processing in terms of gRPC is like the total time it has taken around 832 milliseconds, where in case of REST it has taken 404 milliseconds. So if we do divide 832 divided by 40, so CPU were able to handle 17.33 requests. Actually, it was taking 17.33 milliseconds for each request, right? Which is quite amazing compared if you compare with the rest. Streaming is one of the core concepts of gRPC. I mean, it supports multiple stream. We see first is unary, and then we have a client-side streaming, we have a server-side streaming, and bidirectional streaming. So streaming. So when we talk about the unit, it's a simple like how REST work, right? Single request response structure. The client will call a backend, and the backend will give the response to that, right? In case of client streaming, it is similar to the unary RPC, like except the client sends streams of message to the server, and the server respond with a single message. So client will send a stream of messages to the server, and the server respond back with a single message. Next, we have a server-side streaming. In this case, it's a reverse of the client-side streaming. Server sends a stream of messages to the client, and the client will respond back with a single messages. And then we have bidirectional streaming. So in bidirectional, we have seen in case of WebSockets, right? The communication happens with both sides, right? The server can choose send back its initial metadata or wait. So once the connection has been stabilized, the server will or the client will send the metadata. So metadata may include the authentication details and all, right? And once it's get validated, it will start sending the streaming message. So your order doesn't matter. Like, it doesn't maintain the order. It can communicate in any order, right? So server can start sending the messages first, or the client can start sending the messages. Okay, next is a code generation. The prime feature of gRPC methodology is the native code generation for client server application. So we have seen like using the product compiler, right? It generate the compiled code into native languages using this proto compiler. gRPC framework uses a proto compiler to generate this kind of a code, right? And create from your .proto file. And then gRPC again convert into a .base class. We have seen, right? Create a base class file in our previous slides. and then it create whatever definition you have into your profile. It create a server side stub and the client side stub, right? So stub are basically useful for starting the communication between your gRPC and your client, gRPC server and the client server. Next, we have interoperability. So gRPC allows for describing a service contract in a binary format, right? To create a dot profile, but the communication happen into a binary data. Programmers can have a standard way to specify those contracts, right? In like you define in your APIs in the RESTful APIs, right? To have write your expose APIs into your controller file. You actually write everything into your dot proto file, right? All your contracts and everything has been managed into your dot proto file. And it's a language independent, right? Doesn't matter which language you're using, right? Once you create your dot proto file, you can use those proto file into any language. So it's a completely language agnostic. So as we know, like we have seen, like this RPC solution across all the major languages it have a support for, and tooling it has a wonderful tooling capability. But you have to do very less code compared to other framework, and you generate the boilerplate code by the gRPC framework itself. And it's very time saving for the developers, right? To write considerable times enables developer to focus more on the business logic compared to defining or maintaining your services. So these are the built-in support gRPC offer. It provides an encryption mechanism, right? It helps you to encrypt the data into a binary format. Then it also provides authentication mechanism. And next we have a tracing. All these things, like for example, tracing you in terms of REST, right? You need to manage your own tracing system. You need to add certain tracing library, but gRPC provide out of the box, right? And next you have handle timeouts. This is one of the good thing about the gRPC, right? It's you can cancel your request, right? It's not possible with the HTTP one because of the HTTP two. Let's say you make a call to a server, you can cancel your request from your client side. But in case of HTTP one, right, it's basically happen only with the timeout, right? You're not able to cancel the request manually. Then you have interceptor, a load balancing, and then you have a service discovery. These are the features comes inbuilt with the gRPC. We'll talk about the pros and cons gRPC have. gRPC is very fast compared to other protocols. We have seen a test example of performance. It's approximately 7 to 8 times faster than REST. It provides one client library, right? You don't need to have a multiple maintainer. You just have a one maintainer and you use a library from them, and they take care for all the update patches and everything. Then because it's a two-week, it provides a streaming process, right? So you can get a progress feedback, like let's say you are uploading a file, right? How do you know how much data has been uploaded to the server, right? So here the server can actually send back the response to the client, how much the progress has been done so far. The next thing is the cancel request, right? This is pretty much not possible with the other, right? You cannot cancel. You can make the disconnect from the client, but the process will happen on your backend servers in case of REST and all, right? But in case of gRPC, you cancel the request from your client side, and the server also stop doing the processing those requests, right? And next, support for the HTTP2 and the Protobuffer, right? Protobuffer is very optimized and sends the data into a binary format. It helps to reduce the size of the data, and and once the payload is very low, right, it's very help you to improve the performance of your application. Now let's talk about the cons as well of gRPC. So gRPC, the one of the major problem is like defining a schema, right? You need to write a dot proto file and you have to define all your services. into your proto file, right? All your contracts and everything has to be defined. In case of REST and all, right, you define expose your service from server, but the client doesn't need to. It just call an API, right, and then consume the data what server is sending. But in case of, you have to define everything in your proto file to communicate with the client server. And it's still young. gRPC have an active community, and but still, like it has a certain problem, so it's still the gRPC team actually trying to fix those problems, and it's still evolving, I would say. The next, error handling. So in terms of the rest, right, you have a lot of error status code, you get it, right? For example, the bad request, you have a 400, and if you unauthorized, you send a request status code 401 and all, right? But this is missing from gRPC. You have to have your own implementation for error handling. So that's make a bit of required a code implementation around this. Next, we have non-native browser support. So gRPC is not an ideal for making a call from your web application to the backend. It's basically a use where you have a service-to-service communication. So they don't have a library from the gRPC right now for web, but there was a certain project has been created around as a workaround for this using gRPC into your web application. No readable format. JSON and XML are very much readable, right? You can read the data, but here, since the data is being formatted into binary format, you won't be able to read the data. Next, we'll talk about gRPC security. For any framework success, it's all depend on its security as well, like how good the security of these frameworks are. So gRPC comes with the SSL and TLS, right? So gRPC provide out of the box solution for SSL and TLS. Whenever you create a gRPC service, you have to add your certificates, SSL certificates you need to provide, and and this SSL certificates help you to encrypt the data you exchange between your client and server, right? Next, ALT is application layer transport security. It's a mutual authentication and transportation encryption system developed by Google. So ALTS connections are end-to-end protected with privacy and integrity. For application running on GCP, we can implement ALTS. So it mostly with the Google Cloud system. It's not with most of you cannot use on your uh, other platform, right? It's come with the Google application itself. And these are the channel level authentication, right? You do at the channel level. And these are the call based authentication, like whenever you make a call to the method, right? These are like initial handshake security. These are the call, like for every call you have to send the token, right? So it's similar to RESTful APIs. We use a DWT based authentication or OAuth based token support. All these are supported by gRPC, right? You can add your GWT token as a part of your metadata into your gRPC application calls, remote calls. We'll see what are the recommended use cases of my recommended use cases where you can use gRPC. So since gRPC have a very good throughput and very low latency, right? So it's very ideal for to use into microservices world, where it's very important to have a low latency and high throughput actually. And point-to-point real-time communication, since gRPC supports for two-way communication, bidirectional communication, right? So it provide a very good support for real-time application we are building or IoT-based application. Next, we have a network constraint environments, right? gRPC message we serialize into a protobuffer, which are that is very compressed, and it also have HTTP2, which actually have a better mechanism compared to HTTP1 in terms of the compressing the data. So think as a IoT devices, right, where you have low bandwidth, your network is not very much high, right? And you want since there could be chances like these devices lose the network connection as well, right? You need a space into the devices to store the data, right? So where you have a problem with the storage and where you have a problem with the network constant, right? You use gRPC is an ideal solution for those kind of devices or a solution. We'll talk about the key takeaways about the gRPC. So it's a pretty much a new and powerful tool. It has been developed, I mean, open source by Google in 2015. Let's have an active community, and it's being used by a lot of companies actually, big companies, Netflix, and we have given a lot more companies actually, and has a growing community with support from Google and CNCF. It's not a complete replacement for HTTP API, because HTTP is very good support for the web application and all, right? But which is gRPC yet to come or provide a solution around the web application. But in terms of the service to service communication, it's very good or ideal actually if you're looking for the throughput or latency. And it offers a very good productivity and performance benefit in some scenarios like microservice communication and real-time communications. Thank you, everyone, for joining this call. If anyone have any question, please feel free to service to service communication. It's very good or ideal actually if you're looking for a throughput or latency. And it if anybody have any question, feel free to ping on YouTube chats.
Hello. Hello. Can I close the session?
Yeah.